Good morning, friends. Welcome back to our AA session. Today I want to start the new topic, that is Unit 5, that is called learning. So after knowing about agents in the first chapter, after presenting the agent information in some formal languages, after planning in third unit, and after dealing uncertain conditions in the fourth unit, now it is a time to learn. So what is the basic use of this learning? See, learning is needed to get the information, to find out what is the information and to verify what is the presentation you have to make. This is in the beginning scenario, but after performing all this, if you verify the performance of these basic things you done in terms of learning, we have to check whether it is performing well or not. If it is performing well, that is a required concept based upon the agent, it is better. If it is not, automatically we have to learn to perform better in order to reach our goal. So in that scenario, the learning can be done in number of ways, but as a part of our university, we have 6 topics to deal in this learning 5th unit, that is learning from observations, inductive learning, decision trees, explanation based learning, statistical learning methods, and reinforcement learning. So in this you have to concentrate on main statistical learning methods, little bit a big topic in this. The remaining topics are all very easy. We can deal very easy also. Now start. The learning from observations. Okay, as a first topic in this, it's a very easy topic. In this we are going to learn about what is a learning agent. We already know about this in the first unit. Just a revision is going to done. Now the second topic in this is supervised learning, unsupervised learning, and reinforcement learning. So this is a ways by which we can perform learning, that is nothing but the forms of learning. Okay, so this is the theme of this first topic, that is learning from observations. Now, introduction to learning. What is the learning basic things? Okay, so learning is the getting information or to improve your performance. That performance may be from observations, right now. So with this, check the definition once. Learning is a process that improves the knowledge of an AA program by making observations about its environment. Okay, so with this learning, what we do? We do improvement in the performance, which can be useful for future task. Now, how this learning? Why we have to deal this learning agent here? Why? Because if you as a human being, if you want to learn, we can, based upon our knowledge and the memory, the learning will depend upon. For example, for the kids, the learning is very easy because they don't deviate from their concept. But if you are growing as an adult or a man or man, automatically based upon we have things we have to perform daily way. We have lot of things in mind, so automatically we used to deviate. The learning will be different. So, but our problem is to make a machine to learn, nothing but the machine learning. Okay, so this learning have to induce or introduce in our machine called as a machine learning, by which it can do task without human intervention whenever the knowledge acquisition is happened. Okay, and whenever there is a degrade in the performance, automatically it have to devise a new things or elements to perform well, to improve its performance. So with this, what is a machine learning? Machine learning is application of AI that provides the system the ability to automatically learn and improve from experience without being explicitly programmed. Okay, so what is a machine learning focusing point? The focusing point is to make the computer programs to learn itself and to perform themselves. You know about this. Hope you remember this learning agent. In the first unit itself, we have 6 types of learning, if you remember. Okay, so table driven agent, simple reflex agent, model based agent, utility based agent, and finally learning agent. Okay, so in this learning agent we have 4 components, that is a critic, learning element, performance element, and the problem generator. Now, so learning agent element, why we have to use this learning agent elements? If you want to improve this, we have to divide our task in terms of number of modules. So those modules can be n number or 1 number, depends upon your requirement. So but this learning agent, we have 4 categories of learning elements. Okay, see here. If you observe the diagram perfectly, whatever the data you got from the sensors in terms of environment, automatically the critic will give the feedback to the learning element. What the critic will do, it will criticize the data, whether it is a positive, negative data available. The representation available with the environment is not up to our representation, it will give the negative feedback. The data is somewhat different, so you have to make a change. What the learning element will do now? The learning element will make changes to improve its performance. Okay, to improve its experimentation, improve performance. So those changes is going to give into the performance element. So the performance element will do some actions based upon the input you have feed to the performance element. Okay, so those are the whenever the changes is going to done by the learning agent, automatically it will feed those changes to the problem generator also. Here our code to perform your action is going to be generated and feed back to and it is feeded to the performance element in terms of experiments. Those experiments is going to verified by the performance element, it will give the performance. That is, those performance is going to learn by the knowledge, learn in terms of the knowledge to the learning element. Okay, so if it is so, this would see, if you observe this, the critic element is useful for the learning element with feedback from the critic on how the agent is doing and determines how the performance element should do modify. Okay, and performance element, the performance element will do some actions based upon its input receiving and actions you want to perform. The learning element will improve by making changes. The problem generator will do some new things, that is new algorithms, new experimentations. Okay, now learning element, this learning element can be differ from one to another based upon the number of concepts we can deal. So those are how to perform your learning, that is the type of performance you want to use. The functional components, because the functional component playing a vital role, because total functionality is going to divide in terms of number of components. Each component may differ from another. For example, if you take an example of a mobile, one mobile is going to differ from another based upon the features, version, memory, your picture resolution, that is etc etc. Okay, so how this functional component is represented, in which language, in which syntax, in which methodology, blah blah, and what is the feedback, how the feedback is going to do, means how the input is going to do giving to you, whether it is going better or not. We have to criticize something by somebody, so though somebody is going to be by supervised, unsupervised or reinforcement learning. If you observe this table, given some table, some examples I have collected from the web browser. Okay, for example, the performance element, the performance, that is the topics I have discussed here. Design of learning element is dictated by, every learning element should be based upon the 4 factors. The type of performance elements, how you perform, how you verify that, how your functional component should be do, what is the functionality you want to apply for this learning element, how the functional element should be presented, and finally what is the feedback. Okay, now what is a performance element? The performance element can be either alpha, beta, search, or logical agent you want to perform, or utility based agent, how simplex, reflex agent, whatever, how you want to perform, that is up to you. You are the creator of this. The component, so what is the equations you want to use, what representation you want to use. The component may be evaluation function, translation model, perception action methodologies, etc. And the representation, if you want to assign some weights, if you want to do some success state actions, if you want to use bias and networks dependency, or if you want neural networks feedback in the front way or back way, or if you want to use some feedback, that is a feedback element, either if you want to verify whether the win or loss, or if they are going to be outcome, if any outcome came, then it is a feedback, if it doesn't came anything, it is a feedback. Okay, or correct action, if they performed correctly, that is a good feedback. If they didn't perform correctly, that is a wrong, bad feedback. So like this you can justify yourself how your learning element should be. That is up to you, depends upon your requirement. But why we need this learning? I said previously, as a human being we should learn, because we have to take our life as a challenge to lead our life very good manner. So automatically we have to move in every step as a learner. From the beginning as a kid we have to learn from the parents, later we have to learn from the society, later we have to learn from the family members, from the friends, from faculty, blah blah blah, this will happen. But what is a machine learning agent have to do? Why it have to learn is, whenever it is not able to verify the situations, means for example, our owner said to the learning agent, a robot, to place a glass on a table by taking a glass of water. But unfortunate thing is, the robot failed to place that glass of water somewhere. What will happen? Automatically the owner have to verify why it is falling down that glass. Okay, so if it is so, the situations may be changed. For one thing, maybe one more thing is, the owner may not expect all the changes what will happen, because for example, if you verify the corona, nobody expect this corona situation. We used to lock down in the house only by deviating from a normal stream. Okay, we may not expect how you cope up this. So in that case, or whenever the user not able to program well for any type of situation, because as a human being, and we are learning in every stage, we are not in a position to learn everything as a single step. Not at all possible now. So we have to learn step by step, and we can't program it in single step perfectly. So in that cases also, we need a learning agent. Okay, so if you want to do learning automatically to improve performance, then we have to devise the learning methodologies. Those learning methodologies are based upon 4 factors. One is the component what we are going to use, what is the knowledge you have, how you want to represent, and what is the feedback you want to get. So this feedback can be done in terms of 3 ways, that is supervised, unsupervised, and reinforcement. But for everything, the component playing a vital role. What is the steps you want to include in the component in order to perform this learning? Okay, so this learning component should include direct mapping. Means whatever the input you got, that should be mapped to our required output or actions you want to perform at least. What is infer relevant properties? Whatever data you got, how to infer that relevant properties to our knowledge. That is our requirement. Now, how the world evolves, we have to verify. Whenever there is a changes in the environment and the input format, automatically we have to check the evolution. Next, how you are going to get the utility, the benefit, how you are going to measure your benefit, what are the technologies or methodology you want to use, and what is the value you are going to get from every action. Because we can perform lot of actions, but one action may be useful, may not be useful, we don't know that. For example, we are implementing the slip test and one more is the grant test, but some of you are not availing in a better manner. Why? Because based upon your perception you are going on. So what is the value we want to assign is, those who are availing those services, I want to give the value as a 5, that is full, and those who are not availing the service, I want to give the value as a 0 or 1. Right now, so now, and finally, how the goal, have we reached your goal or not? We have to verify that also. We are continuously performing some action, but we are not able to reach our goal. Then what is the value of this action? If you fail to verify your goal, then action is not good. Whenever the action is not good, the utility information what you are going to evaluate is not perfect. Whenever it is not perfect, whenever the world changes, but you are not verifying that world changes. And whenever the changes is not perfect, because your interpretation is wrong. So why? Because your input is wrong, or your input is not relevant to your output. Okay, your input is not relevant to your output. So this is a way if we can map our component, that is the component of learning agent should be. Now, and coming to the type of feedback, because prior knowledge based upon application, a lot of knowledge will be there. We have to interpret that knowledge in some format, and we have to represent your knowledge in some neural networks, semantic networks, forms, rules. These are all the ways we can represent. We learn about these two in the previous sessions also. And coming to the feedback. Coming to the feedback. Who will give the feedback? Is there any person to provide feedback to you? If it is so, very good. It's a good critic. Don't do like that. Please do like that. If any person is there to tell to us, of course we will make him like that only. If it is a wrong feedback we got, if there is any guidance to us, it is better. If there is no guidance to us, automatically our work will become critical, and we have to take more time to perform our action. Okay, how based upon the feedback? We have 3 types of learning: supervised, unsupervised, and reinforcement. If you hope all of you know about this word supervisor one. whenever there is a supervisor to us, means whenever there is an input for us and output for us, we know how to get and we know we know what to get and we have what to get. If it is so, then it is supervised learning. Okay, if you observe this, we have a raw data and we have a supervisor here. The supervisor contains a training data set, means he know how to represent our raw data and he know what is the output to present. If it is so, what is his work, the supervisor work? He is to devise a model that is called as an algorithm, okay, which fits our data into required output. Okay, so in order to perform this, we have to do some processing, that is the changes or whatever you want to do. Okay, after doing this processing, we will get the output. It is supervised learning. And coming to the unsupervised learning, unsupervised means there is no supervisor at all. We have to verify the output. We have an input, that's it. We don't have any supervisor, we don't have any algorithm, we don't have any training data set. It is us to devise everything. Okay, if you see, if you observe this, we have raw input data, unknown output, no training data set. If it is so, we have to interpret our data. The format whatever you have may be not suitable to our output. So we have to devise new thing, that is interpretation. Later we have to find out an algorithm. Later we have to do some processing. Later we have to give some output. Okay, so this is unsupervised learning algorithm. Coming to reinforcement learning algorithm, it's a new one. Whatever the environment we want to choose for our application, every environment after something giving some rewards. Okay, so those rewards are useful to the agent to do some actions. If it is a positive reward, we will continue. If it is a negative reward, we will not continue. So this reward is going to be based upon interpretation, how you see with your eyes. How you see with your eyes. For example, we are getting some unwanted data. What they will do, somebody will try to filter the data and they will extract some useful information. But somebody will remove that total data. It is not relevant to us how to get the new information. Some will interpret like that. So based upon your perception, based upon your model you want to use, we can get the data from the environment itself. If it is called as a reinforcement learning. So this is called learning from the observations, a basic learning method in this 5th unit. Next we will give explanation in deck to learning. Okay, bye.